All right, good afternoon, everyone. Welcome to our webinar, Tableau for the Data Scientist with Corp. My name is Jennifer Walls, and I'll be reviewing some of the housekeeping items before we get started. All attendees will be on mute throughout the presentation. As you are listening, if you have any questions, please type them in the question box. We'll answer the questions at the end of the webinar. Also, we'll be recording the webinar, and we'll send a follow-up email with the recording to all registrants. You'll see now in the chat box that there's a PDF. This will give you a technical guide for integrating R and Python with Tableau. You can follow that link and download the PDF there. It looks like we have most of our attendees logged in now, so we're going to go ahead and get started. I'm going to start with a brief introduction. Corp has been around for over 2 decades and has rapidly grown in the data science space. Today, I have the pleasure of introducing our panelists, 2 of our very talented data scientists, Levi Joseph and Itai Makubise. I'm going to let Levi kick things off.
Corp is a organization, a consulting firm with locations in Atlanta, Austin. We are headquarters in St. Louis, and we're all about powering insight-driven organizations. We do a variety of different capabilities, from more traditional management consulting into both data and digital implementation work. And within today's webinar, we're going to mainly focus on one of our data capabilities, advanced analytics and data science. And again, all of this comes back to turning data into actionable insights and transforming organizations for the digital era. So that's a little bit about us. Moving forward, today we'll introduce some of our topics. That's basically the technologies we're going to use. Itai, my colleague, will then take us through some basics around integration and environment setup. We'll then kind of showcase the power of these types of things with a demo use case around disaster relief, a topic that we Texans, unfortunately, have been intimately familiar with in recent years. And then we'll conclude with a best practices section as well as a Q&A. That being said, I'm going to hand it off to Itai, and he's going to take you through today's 3 technologies.
All right, thank you, Levi. Thank you, Jennifer, and thank you everyone for joining us for this webinar for the Tableau for the data scientist. So just like Levi harped on, we'd like to quickly introduce these 3 software technologies that we'd like to integrate today. So in going over our demo use case, we were looking for a visualization tool that was very ahead of its time, a visualization tool that had a relative ease of use. So that led us to Tableau. All right, and so just to give a brief introduction of what Tableau is basically a data visualization tool that helps people see and understand their data. On that note, it's also a self-service BI tool that helps you connect to your data, analyze your data, and create some really cool visualizations of your data so you can get some intuitive insights from your data. So when it came to this demo use case, we looked for a tool that had a relative ease of use. So this came into play especially when you wanted to leverage some of the geospatial mapping where Tableau has a very core competency in such an area. So that's it for Tableau. We'll go into R and Python. And we kind of have this table here in front of us to sort of give a rundown of both technologies. So both R and Python are programming languages. R built more on the statistical computing language side, whereas R is a fully functional high-level programming language. All right, they both have similar purposes. So both R and Python find themselves being leveraged for data analysis, also using those very rich and extensive packages and libraries that they offer to implement machine learning algorithms. R, like I said, it's more for statistical modeling, whereas your Python is more for your general scripting. Some of the cool features that we find in both of them is that they're both open source. And mind you, even though they're both open source, they do provide enterprise class capabilities. So that's a plus. R is an all-in-one analysis toolkit that lets you analyze your data, clean your data, and as well as visualize it at the same time, and then apply these machine learning algorithms as well. Python, being a full programming language, is very scalable and very extensible, so they both have really good strengths. Both of them are very powerful packages, package ecosystems, supported by the wide breadth of people online on the R communities and the Python communities. Some really cool applications that we see from both of them. Just to pick a few, we find that with R, for instance, we find that R is used at places like Zillow, Microsoft, Twitter, and Airbnb. So as well as with Python, we find that it's being used in Dropbox, Google, Facebook, and ILM. Some of the really cool applications where we see R being leveraged is at Zillow, where they use it to predict house market values, as well as for Python, a really cool feature where you find Python being used is at Dropbox, where they actually develop the whole entire client desktop on Python. A really cool application that we also note here is ILM. Some of you might be actually familiar with ILM, so just to take a minute, just a second to pause and think where ILM might have came from. All right, so ILM is basically an acronym for Industrial Light and Magic. It's the company that's very, very popular and very responsible for the great feature presentation that we watch in Star Wars. So ILM actually leveraged Python because it's very integrable with their technology. So that's one of the cool features where we saw Python being used. All right, and on that note, I'm going to hand it over to Levi to go through the data science pyramid.
Hey, thank you, Itai. So the data science pyramid is basically our preferred framework for thinking about and placing data science within the overall data stack. So this diagram is to some degree meant to be read bottom to top. So starting with data acquisition, these are basically all of your means of actually going out and getting data, whether it is, say, IoT streaming devices, social media, so user-generated data, as well as more traditional ERP or legacy data store type data. And we do a whole range of things around data acquisition for our clients, most of which are centered in our digital practice. Next is data engineering, and this is where you're getting into things like more modern pipeline infrastructures, as well as more traditional ETL, EDWs, and then also maybe more modern enterprise data lake type environments. And data engineering is all about getting your data into the right format to be consumed higher up the pyramid by your users. One thing that kind of goes hand in hand with data engineering is this concept of master data management and governance, again, a core competency of SimsCorp. And this is all about, you have your data, you've acquired it, you've engineered it, but how do you ensure its quality and its usability? And that's where MDM and governance comes into play in terms of, again, really fleshing out that business value from your data. Finally, we get into these top two layers, reporting and business intelligence, as well as data science, which are to some degree the two topics of today's webinar. And what we find in the industry is that a lot of our clients are kind of either at the reporting and business intelligence phase, even if something basic like Excel sheets, for example, or into more robust solutions such as BI tools. But we are not necessarily seeing a lot of our clients, or maybe they're in the nascent phases of actually integrating data science. And there's a component of data science where you're basically automating decisions. There's also a component of it where you want to surface insights that your algorithms have generated and present them in your reporting and business intelligence layer. And that's really the topic of today's webinar. One final thought I want to leave you all with is that despite the fact that this kind of presents bottom to top, and I just read it off bottom to top, that is not to say that you have to be perfect or fully mature in any of these layers before you get to moving on to the next one. And rather, we find that our clients are most successful when they do their due diligence in building up a layer, but they're also willing to kind of move on to the top one and use things they discovered there to inform lower layers. So I'll give you two examples. So you might do some data engineering at your firm. Your data might be maybe out of its raw state and into a better state from, like, for example, you might have an operational data warehouse up and running. And you might want to say, I'm going to spend time getting this data warehouse perfect before I move on to MDM. But we actually find that a lot of our clients are more successful if they're willing to jump to MDM and governance a little bit earlier in their maturity to use some of the lessons learned there to inform the design of their data warehouse. Similarly, data science can be a really powerful tool throughout the pyramid. both in terms of proving early value, so showing stakeholders, hey, this is something we should be pursuing, but also in terms of reaching tangible business goals. And an example I'll give you is we've worked with clients to use data science and machine learning techniques with applications of data engineering to basically do outlier analysis to make sure that their queries or their transformations are working as intended. And so that's just kind of a nifty use case. But again, this is our preferred methodology for placing data science and the overall stack. So now I'm going to hand it back over to Itai, and he's going to walk you through the integration and execution of these R and Python workflows.
All right, thank you, Levi. Thank you for queuing that up really well. So what we'll now look into is the integration and execution of how we actually combine these technologies together. So just before we get into the weeds of how we integrate them, just want to go ahead and just highlight this diagram that we have that shows the overall architecture and workflow once we have all the technologies integrated. We also like to mention that we have attached a PDF within the chat that has instructions on how to download the TabPy. All right, so let's get into the integration and execution. So to integrate, first of all, we'd like to talk about what do we need to integrate. So we've talked about these technologies, Tableau, Python, and R. Just to kick things off, we'll start off the integration between Tableau and R. So the first thing that we need is R. So be it RStudio or R Console, both of them do work, either or. The first thing we like to do in R is to make sure that we do have the RServe package installed. Well, what is RServe is the first question, right? So RServe package is basically a communication channel between Tableau and R. This is where we send the scripts to R does the computations and sends the results back to Tableau with those actionable insights. All right, so the first thing we need to do is install the packages using the RServe package. The next thing we do is we need to call this package, the RServe package, by using the library function. And once we do that, now we have it within our environment. The next thing we need to do is just to start the services, right? So we just do that by typing in RServe and getting it started. Once we get that message at the bottom that the RServe is started, we can switch over to our Tableau instance. In this case, we have it right here. Once again, that's just the integration, architecture, and workflow. We're starting off with the R and the Tableau integration. So once you have your R services started, the first thing you do is you go to the Help menu in Tableau. You scroll down to where it says Settings and Performance. Under Manage External Services Connection, since this is an external service that we like to establish communication with the Tableau. All right. In this case, the RServe is installed on our computer, so it's on our local host. The port for R specifically is 6311, so that's the default port. The next thing you do is you test your connection. Once you get that successful message, quickly close it by clicking OK, and now you can go ahead and click OK on that. Now, this could have been hand wavy. There might be questions asked to say, well, how do we know it's integrated? How do we know we can now start writing R scripts into Tableau? Well, that's a great question. In order to test this out, what we do is, just a moment here. We have scripts to test this out. All right, the first example that we have is a simple example. We have two examples to showcase this. The first example is showcases, let's just multiply two values, right? So we have a priced item for $1,000 and we have a discount code of 30%, right? So if you wanted to calculate a discount value, you basically multiply those two values. So we have a discounted value here, which is a measure that we created. All right, so let's take a look at how we created this measure. It's basically a product of two arguments. These arguments are the price and the discount being the percentage or the fraction of the cost. All right, now you might ask yourself, what is a script reel? Well, script reel is basically one of the four ways that we enter Python or R functions into Tableau. We have four ways. It's either script reel for when we're returning real number values to Tableau, or script integer for integers, or Boolean, or a string, right? So those are the four that we have. In this case, we're using a real number. We would like to return a real value, so we use a script reel. So that's the calculation. Let's see if we can apply this calculation to our discounted value worksheet here. So we just drag it onto the worksheet. And let's see what we can compute. And just to make sure that we've correctly connected to our R services. Notice we get a discounted value of $300 being highlighted here on the right. So for 30%, the discounted value is 300. Now, this might be more elementary, and I know we have very business-minded IT technical people. So let's go ahead and move on to a more involved example where we actually leverage some of R's packages. So in this example, we have profit over year, right, for a company. So we have between the years 2015 through 2018. We'd like to detect, so the use case here is to be able to detect outliers within our profit, right? So how do we do this? Well, we need to define a measure. So just like how we define a measure in the discounted value example, we define this measure being called the outlier. We take a look at it and see how do we calculate this outlier. Now, if you notice here, we now actually use the library function from R, where we library the MV outlier package. The MV outlier package is basically just a multivariate outlier detection based on very robust methods, right? So this is the sort of package we like to leverage from R to use it here in Tableau and actually get those actionable insights. So this is the calculation with the necessary arguments that we'll need. So if it's equal to 0, then it's an outlier. If it's equal to 1, then it's actually normal. It's not an outlier. So we can actually apply this very advanced computation on our profit to actually take a look at outlier detection. So how we do that is basically drag that outlier pill to our Tableau worksheet. We'll let it compute for a few seconds there. Shouldn't take long. At first glance, it seems as if there's no outlier, so we might be happy with that result. But be it that we may have certain questions depending on granularity. If we notice here, we're looking at 2015, 2016, 2017, and 2018. We can actually even go even further and drill down because of Tableau's ease of use and drag and drop features that allow us to even slice and dice our data to even smaller granularities. So in this case, instead of looking at a year-by-year perspective, let's actually break this down to a month-by-month or a quarter-by-quarter perspective. So in this case, we can actually break it down to a quarter-by-quarter. Notice now we actually begin to see these outliers showing up. So in 2017, we actually had one outlier. What if we wanted to even dig deeper into our data and say, well, what if on a month-by-month basis, do we have any outliers? Notice we start to show up with those outliers, and we can now start to analyze our data and to get better insights from our data. We can even go further, even more granular to a day-by-day basis, and notice how we now get more outliers in our data. So those are the two examples to show that we've been able to connect our RServe, our R to our Tableau, so we've managed to integrate it seamlessly. So that does it for this R integration with Tableau. Now we can move over to the Python integration. But before we move on to the Python integration, we just want to switch back to the PowerPoint presentation and just
Awesome, thank you, Itai. So for today's use case, sorry, one second. Cool. So for today's use case, we're going to be taking you through a use case around Hurricane Harvey, which hit Texas recently and caused a large amount of damage to the eastern part of the state. And so we're basically looking at three data sets. The first is kind of just traditional geospatial type data. So think of it as kind of labeled items with a set of coordinates. And here we'll look at items like shelters, food donation drop-off points, as well as medical and pharmacy aid points. And that's going to be basically our initial building blocks. Next, we're going to look at an example of overlay data. So in this case, we'll be looking at Houston socioeconomic data, which we know might be potentially predictive of certain types of either availability of aid or a need for aid. And then lastly, we're going to incorporate a more unstructured data set from Twitter to generate potential supply and demand data, as well as sentiment data around kind of different locales. And the net result of this will basically be a set of dashboards that we think would be helpful to individuals who might be doing things like disaster relief planning or dispatching of aid from point to point. The last point before we move into integration, we're going to be doing pre-processing integration, which is basically using Python to pre-process some data to drop it into a set of files that or a database that our Tableau instance is going to look at, as well as we're also going to be using Python to expose an API endpoint to deploy a model. So before I take you through the Jupyter Notebook to showcase this, I think Itai is going to demonstrate how to get TabPy up and running.
All right, yes. So thank you, Levi, for clearing that up. So in order for us to connect the two technologies, Python and Tableau, just like we did for R, the first thing we need to do is to make sure that the services for Python have been installed and have started. Now, if you look at the chat, we did attach a PDF, and within that PDF, it does show how you download TabPy. TabPy is Tableau Python in short, and this is the server that we use to communicate to Tableau, between Tableau and Python. So we're going to quickly switch over to my desktop here, just a moment. I'm just going to go through the folder structure. So when your TabPy is installed on your computer, it creates an installation folder, the TabPy master folder. And within that TabPy master folder, you can get into the TabPy server folder. And within that folder, you have a startup file that you can initiate. So all we need to do is just initiate that startup file. Just make sure we're up and running. All right, once that's going, we switch back over to our Tableau instance, just like in the R example. All right, so once again, we go through the same commands: help menu, settings and performance, manage external services. The server is still a local host. The port's different. For Python, it's now 9004. We test the connection. All right, we get that good message that everything's going well. We click OK. Once we click OK, notice as we clicked OK on that, the worksheet in the background faded out. The reason why is because at any instance, you can only connect either your Tableau with Python or your Tableau with R. So notice that some of the calculations that we had established earlier for R are not showing anymore because of that reason. And on that note, now that we've integrated Python with R, I'm going to hand it over back to Levi.
And I'm going to take you through Jupyter Notebook, kind of demonstrating how we've done the integration. So first things first, for those unfamiliar with Jupyter, Jupyter is kind of an industry standard type notebook environment for doing data science workflows. And this might look a bit like kind of a combination of like a browser type development environment combined with a more traditional SDK type developing environment. And what makes Jupyter unique is basically it lets you do basically writing text next to writing code, and even basic or even advanced visualizations, all in one workflow. And that is kind of matches up with how a lot of our data science workflows tend to be. It's usually some combination of doing our work, documenting our work, and visualizing data. So this is Jupyter Notebook again. So the first thing I'm going to do is I'm going to configure my environment. So what that's going to do is basically load our necessary packages. The next thing I'm going to do is I'm just going to create a set of useful functions. And so when I look in here, it's everything from kind of more naive type binary classification type stuff, nothing fancy there, as well as all the way down to maybe slightly fancier workflows around or functions around deploying sentiment analysis or doing some parsing to determine labels for example, locations here. So basically, we have a function that can look at text in a text blob and pull out locations. And then we also have various functions around doing different types of sentiment analysis. So basically, you can think of this as kind of like a toolkit for doing NLP workflows. And I'm not going to spend too much time here, just because it's not really necessarily the main focus, though I am happy to answer some questions later on in the Q&A around this. So next thing I'm going to do is I'm going to come down here and I'm going to basically go and get a live tweet. So by running this script, all it's going to do is it's going to, sorry, 1 second. There we go. So as you can see, I wrote this tweet pretty recently, and it basically says, I need toilet paper in KE. It has a timestamp, it has my username, ljoseph2221. And so what that's done is that's went and accessed the Twitter API and basically pulled out my latest tweet. So that's basically just naive, just go get a tweet. Let's do something a little bit fancier. Let's run our analysis. So what this does is it went and it's going to go get this tweet, and then it's going to print out various attributes about it. So at the beginning, you'll see again that same data. I need toilet paper and Katie. My username, a timestamp, as well as a status. So in this case, it's needing. And here it's kind of obvious. It's I need toilet paper. The script can handle things like I want, or I am giving, or I have extra, and it'll assign either needing or giving. Next, toilet paper, it assigns to the goods category toiletry. And then lastly, the location is Katy, which for those unfamiliar with the Houston area, Katy is basically a large suburb. And so it's maybe a little more subtle here is what it was able to do is it was able to extract this term Katy and recognize it as a location and not, for example, a person's name. And that's a combination of the word itself as well as the context in the larger text blob. And then lastly, it assigned a sentiment of basically a slight negative value here, which is indicative of this is a slightly negative phrase. So that's for one tweet. Let's do it for a bunch of different tweets. So here I have a bunch of different handles that me and my colleague have put together. All of whom tweeted different things. So I need food in Houston. I desperately need clothing in Houston. I would love socks in Katy, etc. And what this larger script does is this function creates a data frame of your shelter. So that's basically it's taking your location and it's assigning you to the nearest shelter, the text around your tweet, your status, either needing or giving, and then a series of, one last categorization of type of good, and then a series of binary flags that we're going to use later on in our Tableau file. Before we move on to the sentiment analysis part, I am going to print this data to a text file. So I need to run the one above. Okay. There we go. Awesome. Thank you. And before I go to deploy a sentiment analysis model, and to remind you all, so this is what we did above is a little bit more around pre-processing, using Python to basically transform data in a way that we need. So in this case, taking unstructured data and making it structured. What we're about to showcase below, is more about doing direct API integration. So the first thing I'm going to do is I'm going to go import the TabPy client. And then I'm going to, again, create some functions for sentiment analysis. And here we're using two different sentiment analysis functions. And taking the average, we found that increases the accuracy. And then lastly, we're going to publish an endpoint. And this endpoint documentation can be found in the TabPy documentation for those interested in further information. So that being said, I'm going to hand it back over to Isai, and he's going to take us through our initial dashboard.
All right, thank you, Levi. So we'll switch back over to Tableau. And we'll start looking at our first dashboard, which looks at the data from a BI standpoint. So just looking at basic needs and supplies. So in this first dashboard that we have here, it's basically highlighting some of the relief shelters that we have all across Houston and the surrounding areas. We also have food donations. So from the perspective of this dashboard, we have different filters based on what food donation could it speak to. And we also have we also have an overlay on the data based on the socioeconomic status of each area. So this, from the perspective of a logistics planner or a supply and demand planning perspective, would give you insight as to which areas need more help in terms of where should more of the food donations be concentrated, or if we were looking to supply food in the West, we noticed there's a bit of a division in terms of food donation areas in the West, in the East here. So that's the first dashboard that we have. The second dashboard that we have speaks to the medical attention that people might need during a disaster of this nature. So we do have a pharmacy aid and a hospital's dashboard, where we actually looking at the pharmacies that are open in and around Houston, as well as the hospitals that are serving people all across Houston. We do have filters based on a hospital name. So let's say if you had a particular hospital, if someone tweeted that a specific hospital like Memorial's helping people out in this regard, you can easily filter down to that Memorial Hospital using that filter. So just using basic features of Tableau, very, very intuitive guided navigation that leads you to the information you need. So these are the two dashboards that we have from a business intelligence perspective, where you're looking to analyze your data and you're looking to get to a quick insight for that present moment. Then I'm going to hand it over to Levi to finish over on the next two dashboards where we have the advanced analytics implementation.
Awesome, thank you, Itai. So similar before, we're seeing a relief map with several shelters. I'm going to click download to one shelter because it's a little bit easier to take in the information that way. So I've clicked on this shelter, shelter 32. And for the shelter, I have a series of basically actual versus predicted relief. So basically what this is saying is I have some data that is generated from like known inventory, as well as other data that was coming from that pre-processing workflow we showed you earlier in Python. That's more of a predicted set of data. Or another way of thinking about it is like an individual has said they have this and are going to bring it into their nearest shelter for suspension. So you can see that here when you look at need food versus need food predicted. And there's also, for example, giving medical as well as giving medical predicted. So here we can look side by side and say, so the data here is a little simplistic, but you could imagine a world in which you have a lot of known supplies as well as an unknown inventory that could be coming in the next few hours, and being able to kind of understand what people around you have tweeted that they're going to bring in would help you in dispensing aid, potentially let you dispense aid faster. So another shelter I want to show you is just, again, kind of shows you that here we have needing clothes and needing clothes predicted. Someone's tweeted about clothing, and someone's also tweeted about toiletries that having them. So moving on to our next dashboard. This one's going to be a little bit more advanced. That was some kind of basic stuff. And so this is going to take a second to calculate, because that's actually go and hit the API endpoint and expose tweets. But now you can kind of see, so I remember those 6 tweets from earlier. Well, now I've applied sentiment to them. And so you see where they match is where they're been allocated to a shelter. So for example, this person says, I would love socks and Katie, and saying that it's a positive message versus I desperately need clothing in Houston, which is a negative 0.497 value. So let's take a second to think here. Something here might be a little bit misidentified, and this is indicative of machine learning. So in this case, the I would love socks in Katie NLP algorithm is going to label that as a positive message, despite the fact that it is actually a needing type tweet. So we would actually go back in our workflow and we would tweak the parameters of our sentiment analysis to basically identify that as an error so that future similar tweets wouldn't be misidentified. And this is in comparison to a very accurately identified tweet. I would be happy to give medicine in downtown, which is an overwhelmingly positive value. And so just to get a larger level, this type of analysis lets us automate some of the insight gathering around understanding disparities of need. So you could, for example, have 2 counties, both of which are asking for or seem to be in need of a similar amount of supplies. But in one of those counties, the words being used around the request are things like desperately need, am desperately searching for, I have a major need for. So kind of more negative phrasings. I mean, this sentiment analysis would capture that nuance and let the disaster relief planner kind of understand, okay, that area is a little bit more hard, it has been hit a little bit harder, despite the fact that that isn't coming through in the numbers, that's coming through in the phrasing. And now we're quantifying that phrasing to make it yet another number. So this is kind of like one of those powerful types of analysis that machine learning techniques, natural language processing, more specifically unlocks to your analysts, and then Tableau is a really visual way of delivering that insight. So with that being said, I think we're going to go back over to PowerPoint, and we're going to conclude with some best practices, and then we'll eventually have a Q&A section. So if you all have any questions, we'll be able to get to them there. So now I'm going to hand it over to Itai, who's going to take us through best practices for Tableau.
Thank you, Levi. So for this best practices slide that we had, we included best practices that we implemented during this use case, during this demo. So the first thing we implemented with Tableau was to be able to speak to the visualizations, to make sure that the visualizations were very intuitive and very easily interpretable from a business perspective. So someone looking at the visualizations would prefer for them not to have to decipher every single chart on the visualization should just speak to the person the moment they look at them. So we wanted to make sure that we had the right visualization. And Tableau did a great job of this by being able to leverage their geospatial mapping. We also wanted to make sure that we selected value add metrics. So metrics that would help us identify, metrics that would help us solve and identify a problem. So in the instance of needing and giving, we were able to identify metrics in the sense of needing shelter, needing food, needing clothes, and things of that nature. So these metrics were things that we implemented within the demonstration in order for us to be able to better track the performance as we supply and give needs to the disaster relief effort. The third thing that we looked at when it comes to best practices on the Tableau side was being able to connect to all of our data. And Tableau did a great job of this because we were able to connect to different data sources, and Tableau was able to connect to flat files, JSON files, web data connectors, you name it. So it was very good to have all our data at one point, and this leads to a single source of truth, having your data all at one point. Now that we have all this data in a central repository, this allowed us to be able to step into the fourth best practice here, which is being able to create a holistic dashboard, being able to connect to all your data and speak to it in one dashboard. So by doing that, we're able to give a complete 360 view of the entire story within one dashboard. All right, I'm going to go ahead and hand it over to Levi to go through the best practices for Python and R.
Awesome. Thank you, Itai. So the first best practice is just to get started building machine learning models as soon as possible. Luckily, there's also technologies like R and Python make that a lot easier. But we have found that our clients who do early POC work around this do a better job of convincing business stakeholders that there is basically value around machine learning. And also part of this is that machine learning models can help with other layers of your quote data analytics pyramid, whether it's data engineering or master data management and governance. Machine learning is just, we find, adds a lot of value to modern day enterprises with large data volumes. That being said, machine learning, while in my opinion is very cool in a vacuum and in an academic sense, from a business perspective, needs to be kept relevant. And that's all about spending a good amount of time thinking about the problem you're trying to solve and formulating it correctly into something that you basically can apply these advanced mathematical concepts to. And we also find that with our clients that this is really a kind of a partnership step in the process where, you know, we have our idea of the problem, but we try to kind of make sure that it's in line with the client's perspective of the problem, and that we're also leveraging their subject matter experts combined with our data science expertise to make sure that we're coming to the proper formulation. The third best practice is to basically minimize moving algorithms and data, and this comes back to basically minimizing complexity within the IT organization. If I can build a model once and say expose insights from it to Tableau, to automate workflows in maybe a digital platform, etc. I'm basically minimizing rework versus building, you know, custom algorithms for those two different use cases. And as this translates here is things like that, that API deployment that we showed you, and that's a good example of, I might have built that machine learning model in Jupyter for another part of my enterprise, and I can just deploy it, and then if other analysts in my enterprise want to access it, all they have to do is hit that API endpoint versus having to build their own model. And then the last best practice is just basically to thoroughly test your machine learning models before deployment. So we saw today in today's use case that we basically, our model misidentified the sentiment of one of our tweets. We want to test that with business users. So for example, that might not be immediately apparent to me as a model builder, but I could take that to a disaster relief planner, and he could look at that tweet and he could say, hey, like this doesn't look like a positive tweet. So that's an example of testing, and throughout this, really consider the ethical implications of your work as well. And machine learning and buzzword terms like AI have been in the news. There's lots of concerns around what their impact will be on our economy and the potential for bad decisions to be made. So you just want to make sure that you're really testing what you're doing before operationalizing it into your firm. So we'll conclude with just kind of 3 final thoughts. First, the entire point of these integrations and the use of tools like Tableau is to create a single source of truth within your organization. And traditional BI does that, but we think that BI plus data science does an even better job of this single source of truth. Next, we think that being able to surface insights to Tableau is a better way of enabling predictive capabilities. You can have a data scientist create a brilliant algorithm on his computer. He might pat himself or she might pat herself on the back. But if that insight is never delivered to stakeholders' hands to make a decision, is it truly enabled? We think, again, that visualization is a powerful technique for doing that. And then lastly, all of this goes towards augmenting decision-making. And this is something we try to explain to our clients is machine learning and data science is not about taking humans out of the loop or removing them entirely. Maybe there are some use cases where there's like jobs we don't want to do that we'd rather offload to a machine. But we think there's a lot more value in augmenting decision making and basically saving you from having to, for example, read through thousands of different tweets to get a sense of the sentiment in your neighboring communities. Instead, let's have a machine learning algorithm determine that sentiment, and then you can consume that data and make a decision accordingly. So with that being said, this concludes our webinar. We have a few minutes to take some questions. And then here you will find our contact information. We can be contacted directly via our emails. You can also tweet at us or contact us on our Facebook page. And then I would direct you to our website under contact for any business-related inquiries. So that being said, you can go ahead and submit questions, and we'll do our best to answer them from the chat. Cool, thank you. So the first question we got are, what are some other applications of natural language processing? So NLP is basically like a subset or a subtype or a subproblem of the larger data science umbrella. And it all gets around how do we basically take statistical approaches towards processing spoken or written data. And this solves a kind of a larger problem around the general complexity of human language. Things like joking or sarcasm or like the multiple use of the same word. And so what natural language processing does is it gives us a better, more efficient way of solving those types of problems. And I'll give you an example. Rosetta Stone was a very popular dictionary and translation software, and it basically used a giant dictionary of phrases or of common context to deliver kind of natural language processing type abilities. When Google Translate came out, it blew it out of the water, and a lot of the underlying technology in it was more statistical in nature and took a more statistical bent towards dealing with data. A really common use case of natural language processing is basically targeted ads. So I can take information that you, for example, posted on social media, and I might be able to parse that and kind of come up with some kind of profile around the type of person you might be so that I might better target ads at you. And there's a lot of benefits around this as a consumer in terms of receiving more personalized ads. There's also potential for some malicious uses in terms of, for example, steering public sentiment. That's an example of an area that NLP might be used.
All right, we have another question here. It says, which is better for this integration, R or Python? That's a great question. So as we've demonstrated within the demo, we've demonstrated integrations for both technologies, both R and Python. So depending on your data science workbench, so if you have more R users, or if you have more Python users, or if you have data scientists who are actually good at both, that's even better. There is no really nitpicky way to say we should actually only just do the integration with R or with Python. We've developed a way to, we've shown you, we've demonstrated a use case using Python, but we could have equally have done that using R as well. Similar to the MV outlier package that we noticed in the example where we executed the R script. We can find similar outlier libraries within the Python world as well. Something also to note is that when looking at these two technologies, the moment we integrate them to Tableau in itself is an advantage. So when we integrate R with Tableau versus using a generic RDBC connector that we'll use within R, we're now actually using a very native connector within Tableau that's actually specific to that data source. So that actually gives it an up. So be it that you integrate R with Tableau or Python with Tableau, you still get that added advantage of being able to connect to your data source in a very accurate way versus using generic connectors you would use outside of those.
So the next question we got is, how does Tableau's integration with Python and R compare to other BI tools? So there's a whole host of other BI tools, things like Power BI or MicroStrategy, and they basically approach integration in different ways. So some of them prefer to integrate more in a direct sense, where they're actually incorporating like the R language as modules within their framework or within their existing software, while others will do more of this kind of like API endpoint style integration, where you're going to call your model, and then some offer both. So for example, Tableau even offers native machine learning capabilities that, to my understanding, I think are written in Python. But yeah, the vast majority of kind of like modern enterprise BI solutions will do these types of integrations. It's more a question of how, and then I'd say one best practice that we would recommend is that you want to get a good sense of how configurable the existing modules are. A lot of data, I guess a lot of good data science comes down to these really small and subtle tweaks to parameters or modeling approaches, and some of the more like module-based or GUI-based data science workflow tools can remove some of the controls around those parameters and ultimately can yield less accurate models and can kind of get you into deep water pretty quick. That being said, we've done integrations for MicroStrategy. We'll be presenting on them at MicroStrategy World. We've also done more POC related work around Power BI, and then obviously this work in Tableau. So we got a question around integrating HTTPS connections with RServe and TabPy. I've actually never had experience doing that type of workflow in TabPy specifically, though it's my understanding that RServe should support that, though we always recommend that for those kind of more nuanced things that you refer to the actual documentation, and they should kind of give you a better understanding. Yeah, sorry I couldn't answer that more specifically.
All right, thank you everybody for attending our webinar, Tableau for the Data Scientist, and we hope you enjoyed the content we reviewed today. You will receive a follow-up email with the webinar recording and a link to sign up for our next webinar, Closing the Last Mile of Advanced Analytics. If you have any additional questions, feel free to contact Levi or Itai directly with the email provided on our introductory slide, or visit sensecorp.com. Again, thank you for joining us and enjoy your Friday.